Hey everybody, welcome to AIT 1003, the fundamentals of hydraulics and pneumatics. My name is Mike Deal and I am going to be your instructor for this class. This is a very fundamental class as far as fluid power is concerned. Some of you may have kind of extensive experience with this out in the field, and it's going to be a very fundamental class for you, but I'll almost guarantee you that you'll kind of fill in some gaps in your knowledge and perhaps remember, kind of refresh on some concepts. Some of you may have not ever been around fluid power, whether that's hydraulics or pneumatics, and that's okay because we are going to start at the sort of brass tacks level. So don't be intimidated or anything like that because I am going to take it down to the very fundamental level because there's a lot of information that we've got to get down in our foundation because you will not forget and you will not use this information going forward in the program, okay? This is fundamental information you're going to use again and again and again throughout this program. So if you're not going to take a quiz, forget that information, move on to the next quiz and keep forgetting. We're going to continue to revisit this information again and again because you got to get a good solid foundation, which includes some math, but we're going to contextualize or give you an application for that math. So it's going to be not nearly as daunting or intimidating as you probably think. So we're going to step through some things like that. My background with fluid power is my first career was in aviation, civilian aviation, where we use fluid power systems on airplanes for control surfaces, also landing gear, and several other things too. So fluid power as far as hydraulics and pneumatics on aircraft. Moved into industrial maintenance and even used servo hydraulic robots and hydraulic systems throughout my career in industry, which spans about 21 years. But anyway, a few things to help you be successful in this class, and they're really quite simple. Number one, as I'm lecturing, take notes. Don't write everything I say down, okay? But hit those key points. And these key points will be on the slides behind you. I'm not going to have you go through slideshows and things like that. I'm going to be doing the teaching for you, to you, okay? So as I write, as I speak, and as I go through these slides, be sure to write things down that are key and important because you will need them and on the quiz, but also it's going to be one of those things that you're going to need to get solidly ingrained in your mind, okay? The other thing is that as you're reading your textbook, grab yourself a highlighter, highlight the important things, not every word in that book, but highlight the important things, and you'll hear me talking about them as well. And then also finally the lab experience. When you come into lab, you're going to want to make sure you take some notes because we're going to be doing some figuring calculations. We're going to take do a lot of disassembly of components, and it's going to have some questions that you need to answer in lab that you'll see on the quiz. And again, the quiz is not the most important thing that I want you to get. While it is important to you, I know, I want you to get this stuff fundamentally set in your minds because again, when you get out of this class, it's not like it's going to go away. I promise you, you're going to see it again and again and again throughout the fluid power classes of this program. So I like to keep these videos relatively short, somewhere between 15 to 20 minutes. I may have to break up a lecture into 4 or 5 segments into 15 to 20 minutes to cover all the material, but it's better than an entire hour, hour and a half lecture of just straight on lecturing, okay? It helps me because it's easy to upload. It helps you because it gives you a break. And it's also, if you need to find information, you can say, hey, I remember that was in the 3rd installment. I'll go find it somewhere in that 20-minute span as opposed to trying to find it in an hour and a half. So that's sort of how I do things in this class. So again, I don't want to take up a lot more time with that, but I do want to talk to you a little bit about it, okay? And this introductory lesson right here is primarily for the folks who have never been around fluid power or think they may have never been around fluid power. I'll bet you have. First of all, what is fluid power? Fluid power is hydraulic or liquid and pneumatic, which is gas, could be air or a gas. These are the technologies used to transmit power from one location to another. In other words, we want to move something, okay? We're going to do it through fluid power, okay? And as I stated, and we'll go into it more and more, it could be liquid as a hydraulic fluid, oil, which is an oil base. It used to be water a long time ago, but now it's almost always hydraulic oil or gas, which could be an inert gas, or air, and it's mostly air, the atmospheric air, to use to transmit this power and move things. That's what we're ultimately wanting to do, okay? So, for those who think they've never been around hydraulics, if you've ever seen one of these ZTR mowers, or ever been on one, or even if you've got one, a tractor type lawnmower with a hydrostatic transmission that can go backwards and forwards with the push of a pedal, okay? You're using hydraulics, okay? What you're doing is you've got a pump here with fluid in these lines, and these levers up here are shifting valves to direct that fluid. And what they're doing is they're directing the fluid to a hydraulic motor, okay? We're going to talk a lot more about this, so don't get too tied up on this, but they're porting hydraulic oil to a motor to make this shaft spin. That shaft then is converting that fluid flow into rotary motion that's hooked to the wheels, so they start moving, okay? And again, you're shifting these valves, and we're going to talk a lot about valves, the direction of the oil to and from those wheels, whether it's forward or backwards, it makes it spin on a dime. So if you've ever been around ZTR mowers, or used one, or been around where it's in, that's fluid power right there at play, okay? If you have been around on a farm, I know you know hydraulics have these cylinders that retract and extend, and when they extend, they raise the end loader up, the bucket here on the end of the tractor, raise it up and down, okay? So fluid power at work there, and there's a host of implements that you hook to tractors, and combines have them and everything. So the farming industry is just loaded with fluid power. For those who have been around farms, raised on farms, work on farms, you know what I'm talking about, okay? Almost everyone has driven a car with an automatic transmission. That is a fluid power system, because we're taking the rotary motion, the mechanical motion energy from the gasoline engine and run through a torque converter that builds pressure, going to a transmission that then ultimately converts that to rotary motion for an axle down to the drive wheels, okay? So fluid power at work in an automatic transmission. So there's yet another example you may not have thought about, okay? Also, speaking of automobiles, you got your brakes, okay? It's not a pump, so to speak, like this run by an electric motor or gasoline engine or anything like that. But you've got brake systems that when you press the brake pedal, it forces fluid out to each of these calipers to extend and pinch the rotors, brings your vehicle to a stop. Very simple hydraulic system. Your power steering system is also a fluid power system. Pumps and cylinders that make the wheels turn left and right depending on how you turn that wheel, which is basically actuating a valve. So fluid power system there. Simple floor jack, okay? Got hydraulic fluid in there, use that. We're taking a small amount of energy, and we're able to convert that into a great deal of force to raise and lower a vehicle, which is substantial weight. Even a sprinkler, now we're not really doing much work with the sprinkler as far as moving things for us in, like you'd think, an industrial environment, but we are taking the flow of water and turning it into rotary motion, okay? Spinning, that is our work, the spinning head on that sprinkler system right there, the sprinkler head. So those are some very simple, basic fluid power examples that you may or may not have associated with when you think about, well, I don't know anything about fluid power. But now in a more industrial setting, this is a huge press, okay? And they take a flat sheet of metal and they stick it in the press, and with hydraulic pressure, they drop this ram and force this mold down on top of the sheet metal, and it comes out this shaped form. Looks like maybe the side of a minivan, okay? So I've had experience with that in the automotive industry as well. That's one industrial application. Another one is a fork truck. You see a lot of these in plants, and they are using the hydraulic cylinder on the fork, on the mast, to raise and lower the forks, pick up extremely heavy loads, okay? And also for scissor lifts, okay? JLGs, some of you maybe have experience with JLGs, another type of man lift, and they're using hydraulic pressure to raise and lower cylinder, to extend and retract cylinders that again raise and lower these baskets. So, just different ways of looking at hydraulic pressure. Now, pneumatics is, we said the same thing, except for it's using a gas or air, and primarily it is air in any applications you're liable to see. But it's using this, and it's creating a pressure, but both positive and negative, okay, which is a vacuum. You'll see vacuum being used on suction cups for material handling robots. That comes from generating a vacuum, which is another pneumatic system, or the positive type pressure that you're probably more used to seeing. But we create it with a compressor, and again, we try to turn that fluid power motion movement into some type of work, whether it's rotary, like we talked about with the ZTR mower, or linear. And by linear, we usually convert that energy through a cylinder. It gives us not a rotary motion, but a linear actuation on a cylinder. And you're going to get a lot of exposure to cylinders and actuators as well, or rotary actuators as well. Okay, so again, fluid power is hydraulics and pneumatics. Okay, simple examples for that you might have seen when you go to have your tires rotated, or possibly new ones mounted. They're going to typically use an pneumatic impact wrench. Okay, we're taking the air pressure, converting it to rotary motion. It delivers a tremendous amount of power to pull these lug nuts off. Okay, air nailers that you use in construction, even down to dental appliances that you're using as far as to clean your teeth, things like that. Drills. Okay, that's all pneumatics. Okay, it's driven by an air pressure that's supplied by an air compressor. Okay, and speaking of which, I bought one of these. I don't know why I did this. It's kind of cool. I saw it one day, and I asked the guy if he wanted to sell it. This is an old antique dental air compressor. It's got a motor that drives a pulley that then turns a pump, and it's a reciprocating pump, and it delivers air down into the holding and receiving tank down here. But I don't know, I just bought it. It's kind of cool. I don't like the way it looks. It chugs along when it runs. I think it was made in 1909, if I'm not mistaken. I did some research, found it. But anyway, it's something cool. I thought it would be kind of neat to buy, and so my wife loves it. Yeah. So anyway, the dental equipment is used by that. And all of this fluid power, we owe all of our knowledge today, we owe it all to a guy by the name of Blaise Pascal. And you're going to learn a lot about him. We're not going to go into history lessons, but we're going to talk a lot about what he discovered, some of the laws and principles that he discovered, and they are still applicable today. They were spot on in his day, and they're still applicable today. So again, I like to keep these lectures, video lessons here kind of short. This is really not so much a lesson. We didn't really get into the technical aspect. It was just a very simple introduction, and this is kind of give you an idea of how we roll. So I'm going to conclude this video, and you're going to want to open up the next one. We're going to start getting a little bit more technical. But as I always say at the end of all my lecture videos, if you have any questions, by all means, contact me through email or find me in the lab, or call me on my office phone. We'll set something up, and we will answer any questions you got. If you have any problems, there's no reason you can't succeed in this class. I will work with you, our lab instructors, any AIT faculty will work to help you succeed if you will put forth the effort. That's what we look for. And so with that, I'm going to shut this one down and go ahead and start the next one, and we will begin a little more in-depth discussion about fluid power. Thanks for watching, and we'll see you.